moving too fast. Left my morals in the past. Not sure how we gonna last. Got my money doing laps, but it's so hot. You look too good in my old car. Life's not fair, take a selfie. Moonlit hair got me so weak. In the backseat, stretch around like you got me. Most these girls tryna front me. Move too quick for the plan B. Got me so hot, so funny.
Public isn't that controlling?
Life's not fair, but it can be. Stretch around like you got me. Life's not fair, but it can be. Stretch around like you got me. Life's not fair, but it can be. Stretch around like you got me. In the backseat, stretch around like you got me. Most these girls tryna front me. Move too quick for the plan B. Got me so hot, so far need a green card. Life's not fair, but it can be. Stretch around like you got me. Think I'm moving too slow. Kick off thoughts to the door. All your fear, let it go. Watch it drop to the floor. Still it's so hot. You look too good for the soul car. Life's not fair for a deadbeat, but right now I'm feeling comfy. In the backseat, stretch around like you got me. Most these girls tryna front me. Move too quick for the plan B. Got me so hot, whip so far, need a green card. Life's not fair, but it can be. Stretch around like you got me. Life's not fair, but it can be. Stretch around like you got me. Life's not fair, but it can be. Stretch around like you got me. Life's not fair, but it can be. Stretch around like you got me. Life's not fair, but it can be. Stretch around like you got me.
to a lesson on graphing linear inequalities into variables. We'll be following the steps outlined here for graphing the solution set of a linear inequality into variables. So for example, one we want to graph the inequality y is less than 5 minus 3x. So step 1, we write the inequality as an equality statement, which means write the inequality as an equation. So step 1, we write y equals 5 minus 3x. Step 2, we want to graph a linear equation. This is the boundary region of the solution. But also looking at step 3, we need to determine if the line should be solid or dotted, sometimes called dashed. And this is based upon the original inequality symbol. If the original inequality symbol is less than or greater than, we draw a dotted or dashed line. If the inequality symbol is less than or equal to or greater than or equal to, then we draw a solid line. A dashed line indicates a line is not part of the solution. A solid line indicates that the line is part of the solution. So notice our inequality symbol here is less than, and therefore we will have a dashed or dotted line. And now to graph the line, notice how the equation is in slope-to-intercept form, where b, the vertical intercept, is equal to positive 5, which would be the ordered pair 0, comma 5, and m, the coefficient of x, is equal to negative 3, so we have a slope of negative 3. But let's write negative 3 as negative 3 over positive 1. So now we'll graph our line, but we'll graph a dotted or dashed line. So we plot the vertical intercept, 0, comma 5. And now because the slope is negative 3 over positive 1, to find additional points we would go down 3 units and right 1 unit. So down 3, right 1. And we'll do this several times. Down 3, right 1, down 3, right 1. Let's go ahead and graph our line, which again is going to be dashed or dotted. For our final step, step 4, we choose a test point and substitute it into the original inequality. If the test point satisfies the inequality, we shade in the direction of the test point. If the test point does not satisfy the inequality, we shade in the opposite direction or opposite side of the test point. The easiest test point to select would be the origin, as long as it's not on the line. So this point here, which would be the ordered pair 0, comma 0. So using 0, comma 0, we'll substitute 0 for x and 0 for y into our inequality. So we'd have 0 less than 5 minus 3 times 0. Simplifying, we have 0 less than 5, which is true. So we shade in the direction of the test point, or the same side as the test point, which would be this region here. This region, not including the line, contains all the points that would have ordered pairs that would satisfy the inequality y less than 5 minus 3x.
Three, two, one, go! it's a force field. I wear my heart up on my sleeve like a big deal. Your love pours down on me, surround me like a waterfall. And there's no stopping us right now. I feel so close to you right now. Stopping us right now. I feel so close to you right now.
Example 2, we want to graph the inequality 3x minus 2y greater than or equal to 6. So we first write the inequality as an equation. So we have 3x minus 2y equals 6. Notice how here, because the inequality symbol is greater than or equal to, we will have a solid line. To graph our line, let's write this in slope-to-intercept form by solving this equation for y. So we'll subtract 3x on both sides. Simplify. We have negative 2y equals, we can write this as 6 minus 3x or negative 3x plus 6. Let's write this as negative 3x plus 6. Dividing both sides by negative 2, we have the equation y equals positive 3 halves x, and this would be plus negative 3 or just minus 3. So notice here b is equal to negative 3, which means the vertical intercept is the point 0 comma negative 3, and the slope is equal to positive 3 over positive 2. So we'll go ahead and plot the vertical intercept of 0 comma negative 3, which is here. Because the slope is positive 3 over positive 2, to find additional points we would go up 3 units and right 2 units. And again, we'll do this several times. Up 3, right 2, up 3, right 2. Remember, we can also think of the slope as negative 3 over negative 2. This still simplifies to positive 3 halves. In this form, though, we can go down 3 units and left 2 units to find additional points. If we wanted to do that here, we would go down 3 and left 2. Notice how this point is still on the line. And again, we're graphing a solid line, which indicates the line is in our solution set this time. And that's because of the equal part of the inequality. And now we'll select a test point to determine whether we shade on this side or this side. Let's use the origin again because it's not on the line. So we'll test the ordered pair 0, 0. Substituting this into the original inequality, we'd have 3 times 0 minus 2 times 0 greater than or equal to 6. Simplifying, notice how this is 0 and this is 0, so we just have 0 is greater than or equal to 6. Well, this is not true or false, and because the test point was on this side of the line, we shade in the opposite direction on the opposite side, which means our solution set this time is on this side of the line. Which means this region here, including the line, contains all the points that would have ordered pairs that would satisfy the given inequality. Let's look at one more example. Step 1, write the inequality as an equation. So we have y equals 2x. Step 2, graph the line and also determine what type of line to graph. So notice how the visual inequality here is greater than or equal to, which means the line is going to be part of the solution, and therefore we draw a solid line. Y equals 2x is in slope-intercept form. If we wanted to, we could write plus 0 to help us recognize that b, the vertical intercept, is 0. So if b equals 0, then the vertical intercept would be the origin, 0, comma 0. And notice how here we have a slope of 2, which we'll write as 2 over 1 to help us graph. So now we'll go ahead and graph the line. Again, we're making a solid line. So we first plot the vertical intercept, which is the origin, here. Because the slope is positive 2 over positive 1, to find additional points, we would go up 2, right 1, up 2, right 1, up 2, right 1. Or if we wanted to, we could write the slope as negative 2 over negative 1, which means we could go down 2 and left 1 also to find additional points. So down 2, left 1, down 2, left 1, down 2, left 1. Again, we set a solid line because the line is in our solution set. Now we want to select a test point to determine which side to shade. In this case, we cannot select the origin though, because notice how the origin is on the line, which is our boundary. So let's select a different point. Let's select this point this time, where the ordered pair would be 2, 0. So using the ordered pair 2, 0, we substitute 2 for x and 0 for y. So we would have 0 greater than or equal to 2 times 2. So we have 0 greater than or equal to 4. This is false or not true. So we shade in the opposite direction or opposite side of our test point. So we selected this test point here, which was not true or false, which means we shade the other side, or in the opposite direction, which would be this side here. This region, including the solid line, contains all the points that have ordered pairs that would satisfy the inequality y greater than or equal to 2x. I hope you found this helpful.
There's no stopping us right now. And there's no stopping us right now. And there's no stopping us right now. I feel so close to you right now. Didn't know you would chill like that. Like that. Like that. Like that. Didn't know you would chill like that. Like that. Like that. Like that. Didn't know you would chill like that. Didn't know you could move like that. Two-step real smooth like that. All night get down like that. Turn around, make it bounce like that. Didn't know you could hang like that. Sipping on champagne like that. Turn up, get ill like that. Didn't know you would chill like that. Didn't know you would chill like that. Like that. Like that. Like that. Didn't know you would chill like that. Like that. Like that. Like that. Didn't know you would chill like. Didn't know you could move like that. Two-step
Okay. So I watched this though. Wait. Oh. Okay. All right. We had an equation. All right. What we doing? Where we going? Oop. bum, 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 bum. Oh, it is a solution. I didn't see the negative. All right, that makes sense. Cool. All right, let's see here. So for the inequality y is less than or equal to x, do the following test points satisfy the inequality? Let's find out. All right. So we'll do y. is less than or equal to x. We'll do, that's lame. So 3, it does not. Okay, 14 is x. This one does, and this one does as well. Okay, so that was the easy one. Didn't have to write that one down. So we got y 2x minus 7. So 3, 7. So we'll do x and y. That one does. Okay, next one. Fifteen. Body, work your body. So if I want to do that, we'll just solve for y, yeah? Oh. Yup. Okay. Mm-hmm.
I had the wildest dream last night. In Ibiza,
Okay,
right
which
across from Ushuaia, there was a fucking DJ in the
okay
bathroom.
is
9 p.m. on a fucking Friday. It's 9 p.m. on a fucking Friday. Get the fuck, get the fuck. It's 9 p.m. on a fucking Friday. It's 9 p.m. on a fucking Friday. Get the fuck up. We're going to high. Let's go. Let's go. Let's go.
oh, I get it. Okay, okay.
Let's go.
So this right here confused me at first.
Let's go. Let's go.
See, like this confused me at first. I'm tracking. So you pick the bottom. Okay. Let's see, yeah. One step in sketching the graph of a linear equation. Linear inequality is to determine which side of the line to shade in.
Mr. Bouncer, sir, I really have to get in. I need a piss. Damn it, Brittany.
For example, to shade in the upper. Who the fuck is Jared? Okay. Find a coordinate pair, x, y, that satisfies this inequality. Often using x equals 0 leads to a simple calculation. Okay. Okay. Any point 0, y, -3 will be on the appropriate side. Oh, with now we're okay. With x is 0. Well, if x is 0, right? So that'd be 8. No. Oh, okay, it's not equal to 8. It's less than 8. Okay. Because it's the less than or equal to, yep. Try the other one. Wait, that's the same one. Alright, well. Alright. Graphing equations and inequalities in two variables. Solutions to equations and inequalities in two variables can be plotted in the xy coordinate plane. Wait, what? Oh, 5. Okay. Okay, so had it right, just wrong format. Okay. E number greater than 1? Oh. Oh. Alright, let's do another one. Because that one was sketchy. So when x equals 0, y is less than okay, find two coordinate pairs when x equals 0. Uh, 6. Does 0 comma negative 6? Okay, let's say x equals 2. Wait. Okay. So 0, negative 6. And then 2, negative 3. And then this point, 0, negative 7. So dotted line anyways. Oh. What? Alright, let's do another one. Okay, y times 2, okay, would be negative 5, yeah. It would be negative 1. How the fuck did I fuck that up? Because negative 6 is less than negative 5. The graph. Is it the same one? It's the same one. Yes. Ah, dotted.
Welcome to Introduction to Basic Absolute Value Equations and Absolute Value Inequalities. Let's first review absolute value. The absolute value of a number is a number's distance from 0. So for the absolute value of 2, since here's 0 and here's 2, this distance here will give us the absolute value of 2. And notice how this distance is equal to 2 units, and therefore the absolute value of 2 is 2.
Mm-hmm.
Because the absolute value of a number is a number's distance from 0, we know distance cannot be negative. Next we have the absolute value of negative 2. Well, here's negative 2 and here's 0. This distance will give us the absolute value of negative 2. And once again, notice how this distance is equal to 2 units, and therefore the absolute value of negative 2 is also positive 2. And now let's consider absolute value equations. Here we have the absolute value of x equals 2. The solution consists of all the values whose distance from 0 is equal to 2 units. We know from example 1 there are actually two numbers that have a distance from 0 equal to 2. X can equal 2, or x can also equal negative 2. So this absolute value equation has two solutions. X equals 2, or x equals negative 2. Next we have the absolute value of x equals 3. Now we're looking for all the numbers whose distance from 0 is equal to 3 units. So looking at the number line, if this is 0, notice how 3 is 3 units from 0. But negative 3 is also 3 units from 0. So once again, we have two solutions to our absolute value equation.
Is this your lesson? Yeah.
Or x equals negative 3. Next we have the absolute
Yeah,
value of
it's
x
just,
equals negative 4. So we're looking for all the numbers whose
What are you
distance
studying?
from 0
Data analytics.
negative 4. Again, we can't have a negative distance, and therefore there are no solutions to this equation.
Because negative 4, you can have a negative 4, yeah.
Inequalities. Let's first consider the absolute value of x less than 2. The solution set for this inequality will be all the numbers whose distance from 0
Isn't that
is
it?
less than 2.
Nah, you can't have a negative absolute value, right?
Is less than 2 units.
You can have you can have a negative number,
Is less than 2 units from 0. So
right? Because you still be, so you can still have like a negative 3 as your absolute value, right? But the way it was showed, let me see, go back. So absolute value of x equals negative 4, right? You can't have a negative value Because regardless if like x is positive or negative, it's still going to be 3 units, right? So negative 3's absolute value is still 3 because it's only 3 numbers from 0, right? So absolute value of x equals negative 4. There's no solution because you can't have a negative number of digits from 0. Does that make sense? They show us this in high school, but more than half of them never use it again after they learn it. Yeah. That's fair. Shoot, I failed regular, like basic algebra, but now I kind of want to, for some reason, do stuff with math. But yeah, so like absolute values should always equal 3, at least from what I've learned so far. Yeah.
The absolute of x less than 2. The solution set for this inequality will be all the numbers whose distance from 0 is less than 2 units. Let's begin by listing some of the numbers whose distance from 0 is less than 2 units. For example, 1 is less than 2 units from 0, and so is negative 1. 1.5 is also less than 2 units from 0, as well as negative 1.5, and so on. So if we think about this, all the numbers whose distance from 0 is less than 2 units would be to the left of positive 2 and to the right of negative 2. We would not include 2 and negative 2
So it'd be
because the
open
distance has to be
parentheses.
less than 2 units, not equal to 2 units. So if we start at 0, we could go right 2 units, out to 2, but not include 2, so we'd have a rounded parenthesis here. And then going back to 0, we could go to the left 2 units, all the way out to negative 2, but not include the endpoint, so again we'd have a rounded parenthesis here. This would be one way to graph our solution set. We're using open or closed points. We'd have an open
Should be
point
like open
on
circle.
2,
Yeah, an
an
open
open
circle.
point on negative 2, and graph between the two values. These two graphs are equivalent. This is our solution set for the absolute value of x less than 2. Now notice how it doesn't ask, but if we did want to express this using interval notation, we'd have the open interval from negative 2 to 2.
With
Again,
open
we don't include the
parentheses.
endpoints, so we have a rounded parenthesis on the left as well as on the right. Next, we have the absolute value of x is less than or equal to 2, which means now we want all the numbers whose distance from 0 is less than or equal to 2 units, which means all the values listed here would also be in the solution set for this inequality: 1, negative 1, 1.5, negative 1.5. But because of the equal part of the inequality symbol, we could also include 2 and negative 2. And of course, this list would continue.
So that would be square brackets or
So to graph
filled
our
in
solution
circles.
set, again, if we start at 0, we can go to the right 2 units. And once we reach 2, again, this time we include the endpoint of positive 2. So we could use a square bracket. And then going back to 0, we could go left 2 units from 0, all the way out to negative 2. And again, we include negative 2 this time, so we have a square bracket. Or using points, we'd have a closed point on 2, a closed point on negative 2, and graph between the values. This interval includes all the values that are less than or equal to 2 units from 0. All the values to the left of positive 2, including 2, and all the values to the right of negative 2, including negative 2. Using interval notation, this would be the closed interval from negative 2 to 2. So we use square brackets, indicating the endpoints are included. And then finally, in our last example, we have the absolute value of
where
x
are you?
greater than 2. So now we want all the values whose distance from 0 is greater than 2 units, which should be all the values to the right of positive
Not
2
home, bro.
or all the values to
Not
the left of negative 2. So if we're going to list some of these values, we have an infinite number of choices, but let's say 2.5 has a distance from 0 that's greater than 2 units, as well as negative 2.5. We could also say 3 or negative 3, and so on. Let's go ahead and graph our solution set. notice how the distance can't equal 2, it has to be greater than 2 units. So if we start at 0 and we go out to the right 2 units, we don't include 2,
Now I'm
we
in
do include all the numbers to the right, so we'd have a random
Washington
parenthesis
State.
opening to the right, graphing to the right,
All the way to
approaching
infinity.
positive infinity,
Mhm.
or going back to 0, we could go left 2 units. We wouldn't include this endpoint, so we'd have a rounded parenthesis here, but then we'd graph to the left. We're using open or closed points. We'd have an open point on 2, graph to the right, open point on -2, graph to the left. Now again, it doesn't ask, but if we wanted to express the interval using interval notation, notice how we have 2 intervals, one on the left and one on the right. And there's 2 common ways to do this. On the left, we're approaching negative infinity all the way to -2, not including -2, so we have a rounded parenthesis, and we could say or. On the right, we have the interval from 2 to infinity, not including 2, and not including infinity. Instead of using or, though, sometimes you'll see a
U.
capital U, so we could also say negative infinity to -2, open on negative infinity, open on -2, union, open on 2, approaching infinity.
Okay, let's see. I think I wrote that down. Pretty sure I wrote this one down. Somewhere. I think I wrote it in my OneNote. But I'll write it in here too. Okay. Okay. Okay, electrical parts such as resistors and capacitors come with specified values of their operating parameters. Okay, the actual value of these parameters may vary somewhat from piece to piece, even when they are supposed to be the same. Best manufacturers can do is to try to guarantee the variations will stay within a specific range, plus minus 1%, 5 or 10. Okay, 680 ohms, plus minus 5%. Oh. So with the resistance R in ohms, Okay. You would like to study all of the numbers that are a distance 35 or less from a number 160. hold on, let's see here. So from a number 160, what? Write this using absolute value. Yeah, I think would it be would it just be oop. Less 35, maybe? Maybe? Hey. So x plus 110, 35 or more. Should be this one then, yeah? X plus 110 greater than or equal to 35. Oh, it's still negative. Okay, minus 110. Okay. Say all the numbers are a distance of 10 or more from a number of 120. Okay. We'll do stated distance 25 or less from a number of oh, this bullshit. Okay. So many numbers. So we got in politics, marketing, etc. We often want to estimate a percentage or proportion P. One calculation is statistical polling is the margin of error, the largest reasonable error that the poll could have. For example, A poll results. For example, a poll result of 72% with a margin error of 4% indicates that P is most likely to be between 68 and 76%. In a made-up poll, the proportion of drivers who plan on buying a new SUV during the next year was 11% with a margin error of 3.2%. Describe the conclusion about P using an absolute value inequality. Okay, so it was 11% with a margin of 3.2%. Curious, I don't know how. Would that just be This is definitely wrong. Okay. We graded, okay. Almost. Oh. Hoy.